Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video we cover section 8.3 continuous random variable. Okay, the learning outcome in these chapters are firstly to find the probability density function, find the cumulative distribution function and its median, and determine the probabilities from a probability density function, and then to find the probability density function from a cumulative distribution function and vice versa. Okay, so in order to explain the continuous random variable, I will show it in terms of the graph. Okay, let's say we have the continuous random variable with a graph like this. Okay, so the graph for continuous random variable, the area under the graph will represent the probability. Okay, area under graph is equal to the probability. Okay, so means the total area under the graph will be equal to 1. So total area under graph will be equal to 1 because 1 is the maximum number for a probability. Okay, so since let's say if we want to find the probability from a point of A less than X less than or equal to B. Okay, so that's mean we want to find the probability in between this point of A and point of B. So the method is to find the area under the graph from point A to point B. Okay, so since this indicates the area under the graph from A to B, so the symbol of inequalities A less than or equal to X less than or equal to B will be the same as probability A less than or equal to X less than B, or also be the same as probability A less than X less than or equal to B, and also will be the same as A less than X less than B. Okay, the symbol of inequalities, whether or not it has the same equal, it still indicates the same value for probability. Okay, so the function for fx, okay, function fx which represent the probability distribution curve. Okay, function fx that represent the probability distribution curve is called the probability density function. Okay, which means the curve that I draw in the graph, this is what we call as the probability density function. Okay, so it will has the following characteristics, which is the function must always be bigger than or equal to 0. Okay, the function fx must always be bigger than or equal to 0, means the graph could never be a negative graph. Okay, must always be at a level higher than y equal to 0. And then the total integrate from positive infinity until negative infinity for the function fx in terms of dx will be equal to 1. Okay, this represent the total area under the graph. Okay, from positive infinity until negative infinity will be equal to 1, and then the probability from point A less than or equal to X or less than or equal to B will be equal to integration from point B to point A of the function fx dx. Okay, so these are the three characteristics for probability density function. Okay, now let's look at an example. Okay, we are given with a probability density function fx equal to kx squared over 2. Okay, so here is the function, and given that this function only available for x within the range of -4 until +4. Okay, so the first thing that we have to do is to find for the value of k, so we can remove the unknown that we have in the function. Okay, so in order to find the value of k, we know that the total area under the graph is equal to 1. So we can mention that integration of infinity until negative infinity of the function fx dx will be equal to integration of 4 until -4 of function kx squared over 2 dx. Okay, and it will be equal to 1 because total area under the graph will be equal to 1 for probability distribution and probability density function. Okay, so next we just proceed with the normal process for integration, which is the kx cubed over 6, and then for 4 and -4 will be equal to 1. So we substitute the 4 and -4. So then we have k 4 power of 3 over 6 minus k -4 to the power of 3 over 6 equal to 1, which we have 64k over 6 and plus 64k over 6 equal to 1. Then we can have 64k over 3 equal to 1, and k is equal to 3 over 64. Okay, so we can summarize, we can make a conclusion that the function of fx is equal to 3x cubed over with 128 after we substitute the value of k back into the equation of the function. Okay, now we take a function from the same example. Okay, function fx equal to kx squared over 128. Okay, we want to find the probability of x bigger than or equal to 2. Okay, so probability of x is bigger than or equal to 2 is actually equal to the area under the graph for the function fx. Means equal to, we want from 2 and beyond. Okay, so since the function already given that the condition, the function is only available within -4 until 4, so means our probability is the area under the graph from 2 until positive of 4, because that is the maximum boundary for the function. So here goes the 3x squared over 128 dx. Okay, next we go with the integration, which is the 3x cubed over 384 for 2. So we substitute, we have 3 4 cubed 384 minus 3 2 cubed 284. So means it will be 1 over 2 minus 1 over 16 equal to 7 over 16. So this is the probability for x is bigger than or equal to 2, which also equal to probability of x bigger than 2. Okay. Okay, next we want to find the probability where x is less than 3 from the previous function. Okay, so this one will be equal to integrate. Okay, since we want a less than 3, so means 3 is the maximum number. So 3 and the lowest one will be the negative 4. 3x squared over 128 dx. Okay, so it will be the integration 3x cubed over with 384, 3 and negative 4. So next, just substitute the value into the function, and that will be 27 over 128 plus 1 over 2. So we have the probability is 91 over 128. Okay. Then the next question is to find the probability negative 2 less than x less than 1. Okay, so this one we just give the boundary as 1 and negative 2. Okay, then the function 3x squared over 128 dx, there is 3x cubed over 384, 1 and negative 2. Then we substitute. So we have 3 over 384 minus 3 negative 2 power of 3 over 384 equal to 384 1 over 16, and then the probability is 9 over 128. So that is the probability for region between negative 2 until 1. Alright, okay, next example, we are looking at another probability density function which has two equations, which is the px plus 1 for region between 0 until 1, and then we have x plus q for region between 1 and 2. Okay, the other part has 0 function. Okay, so the first task is to find for p and q, value of p and q, where we have been given with a statement where the probability in between 0 and 1 is equal to 1 over 2. Okay, so this is one equation, and another one equation that we can have is integration between infinity until negative infinity of the function fx in terms of dx will be equal to 1. So, which is this part will be equal to integrate, okay, from 1 until 0. Okay, from 1 until 0 for function px plus 1 dx plus integrate from 2 until 1 of x plus q dx. Okay, and it will be equal to 1. Okay, so this is for the second equation. Alright, so for this part, if we integrate, okay, we proceed with the integration, will be px squared over 2 plus x, okay, from 1 until 0, and then plus with x squared over 2 plus qx from 2 until 1 and will be equal to 1. Okay, then we proceed with the substitution. We have p over 2 plus 1 plus with 2 plus 2q, alright, and then minus with 1 over 2 plus q equal to 1. Okay, so next we solve for this part will be p over 2 plus 5 over 2 plus q equal to 1. And then p over 2 plus q 3 over 2 equal to 0. Okay, so that is for the first part. Okay, then for the second part, we take the statement given, integrate 1, 0, probability px plus 1 dx equal to 1 over 2, okay, which is the statement given earlier, where the probability from 0 until 1 is equal to 1 over 2. So that only covers for the function of px plus 1. Okay, so we do the integration for this part will be the px squared over 2 plus x 1, 0 equal to 1 over 2. So p over 2 plus 1 equal to 1 over 2. And then we may have p equal to 1 over 2 minus 1. And then multiply with 2. And then we have value of p now is equal to negative 1. So we take this p equal to negative 1, substitute it into this equation. So negative 1 over 2 plus q plus 3 over 2 equal to 0. Okay, then we can have q is also equal to negative 1. So value of p is negative 1 and value of q is also negative 1. Okay, so now we can see the actual function. Okay, now we just substitute back the value of p and q into the function. And now the next task is to find the probability 1 less than x less than 2. Okay, so for this one is just equal to integrate from 2 to 1. Okay, so 2 to 1 is actually within this region, so that will be x minus 1 dx. Okay, so just integrate. So x squared over 2 minus x 2, 1, and then we just substitute. It will be 4 over 2 minus 2 minus with 1 over 2 minus 1, and then the probability is 1 over 2. Okay, then the next question is to find the probability for x bigger than 0.2. Okay, so let's first we draw a line to indicate the region for our function. We have the region between 0 to 1 and to 2. Okay, for x is in between 0 to 1, the function is negative x plus 1. And then for region 1 to 2, the function is x minus 1. Okay, so since the probability when the x is bigger than 0.2, 0.2 is actually about right here. Okay, so we want to find the probability from 0.2 until probability from point x equal to 0.2 until x equal to 2. So that covers two regions. Okay, the first region is the function negative x plus 1, and then the second region is the function x minus 1. So the probability will be like the integration from 1 until 0.2 for function negative x plus 1 dx, and then we plus is the second region, which is the integration from 2 until 1 for function x minus 1 dx. Alright, okay, so then just proceed with the normal integration, negative x squared over 2 plus x. So 1, 0.2 plus, so integration of x minus 1 for region 2 until 1. Okay, we already done the calculation in this part. Okay, so we already obtained the value is equal to 1 over 2. So just plus 1 over 2. So we substitute the value. It will be negative 1 over 2 plus 1 and then minus with negative 0.04 over with 2 plus 0.2 plus 1 over 2. Okay, so we calculate the value and we obtain the probability is actually 41 over 50. Okay, so next is to find the probability in between 1 over 4 less than x and less than 5 over 4. Okay, so 1 over 4 less than x less than 5 over 4 will covers from integrate 1 over 4 negative x plus 1 dx and plus with integrate 5 over 4 1 and x minus 1 dx. Alright, so we just proceed with the integration. This is negative x squared over 2 plus x 1 over 4, and another part will be the x squared over 2 minus x and 5 over 4 1. Okay, just by substituting the value, and the calculation will give you equal to 5 over 16. So that is the probability for the region. And another last one question is to find the value of k if the probability of x bigger than that point of k is equal to 5 over 8. Okay, so our function is actually covers for region between 0 until 1 until 2. Okay, the function from 0 to 1 is actually negative x plus 1, and from 1 to 2 is the x minus 1. Okay, so since from the first question, okay, the first question when I firstly introduced you for this example, okay, there was a statement mentioned that probability of 0 less than x less than 1 is equal to 1 over 2. So means the probability in between 0 until 1 is 1 over 2. And so since the total area under the graph is equal to the probability which is equal to 1, so means for region between 1 to 2 will also be equal to 1 over 2. So total up will be equal to 1. Okay, so 5 over 8. So 5 over 8 bigger x bigger than point k. 5 over 8 is actually equal to 0.625, which is actually bigger than 0.5. So means the point k must be somewhere in between the 0 and 1, because when x is bigger than k, the probability will be 0.625. So this is the only relevant point for value of k must be placed in between 0 and 1. It cannot be placed in between 1 and 2 because the probability will surely be less than 1 over 2. Okay, so now we have already estimated the possible point for k. So we can determine the value of k by knowing the probability from 0 until point of k, which is the 0.375. So we integrate from 0 until point k of function negative x plus 1 dx. It will be equal to 0.375. And then we proceed with the integration negative x squared over 2 plus with x k 0. So that is 0.375. And now we may have negative k squared over 2 plus k equal to 0.375. Okay, then we bring it, we simplify to form a quadratic equation that is negative k squared plus 2k minus 0.75 equal to 0. Okay, then you can factorize and you may have the value of k equal to 1 over 2, or k will be equal to 3 over 2. Okay, so 1 over 2 is 0.5 and 3 over 2 is 1.5. So since we know k must be placed in between 0 and 1, so this is our position for k. So the only acceptable value for k is 0.5 only. K equal to 0.5 only, because 1.5 will be on the region between 1 and 2. Okay, so that is the answer for value of k.